No satellites, no GPS, no way to see the planet from above. And yet, standing at the base of a single mountain with nothing but a rope, a measuring instrument, and a formula in his head, one man calculated the size of the entire Earth and got remarkably close to the real number. His name was Al-Biruni, and what he did next wasn't luck. It was one of the most elegant uses of geometry in the history of science. Here's the actual problem he was trying to solve. How do you measure something you can never see the full shape of using tools that fit in your hands? Earlier, scholars had attempted Earth's circumference using enormous, resource-heavy methods, traveling vast distances between two cities, measuring the sun's angle at each point, a method that demanded caravans, time, and immense logistical support most scholars simply didn't have access to. Al-Biruni found a different way, one that didn't require crossing an empire. He climbed a single mountain near what's now Pind Dadan Khan in modern-day Pakistan, and measured the angle of dip to the horizon from its summit using an astronomical instrument. Then, using the mountain's height and basic trigonometry, he calculated the Earth's radius from that single vantage point alone. Think about what that actually means. Instead of needing two separate locations, vast distances, and coordinated measurements, he compressed the entire calculation into one mountain, one measurement, one afternoon. It was faster, required far fewer resources, and depended entirely on the precision of his instruments and the elegance of his math holding up under real-world conditions. And it held up. His calculated Earth radius came out remarkably close to modern measurements, a result achieved with instruments that, by today's standards, would look primitive, yet were precise enough to get within a small margin of the true figure. Here's the part that should actually stop you. He wasn't just measuring a mountain. He was proving something about the Earth itself that most of his contemporaries treated as unprovable. Al-Biruni didn't stumble into this method. He was already known for relentless, obsessive precision, a scholar who cross-referenced sources, questioned received wisdom, and treated observation as the final authority over assumption. This measurement wasn't an isolated stunt. It was consistent with a mind that spent a career refusing to accept probably when precisely was achievable with the right method. And the method itself was the real innovation. He didn't just get a good number. He demonstrated that a single, well-designed observation could replace an entire expedition's worth of data collection. That's not just a geography result. That's a fundamentally different way of thinking about how to solve a hard problem with limited resources. Engineer around the constraint instead of demanding more resources to brute force through it. Every time a modern scientist designs an experiment meant to extract the maximum information from the minimum data, a single well-placed sensor instead of an expensive survey, a clever proxy measurement instead of a direct one, they're using the same instinct Al-Biruni used on that mountain 1,000 years ago. He didn't have satellites. He had a rope, an instrument, and the refusal to accept that a hard problem required an expensive solution. We think of scientific progress as needing better tools, bigger budgets, more resources. Al-Biruni's mountain measurement is a reminder that sometimes the actual breakthrough isn't a better tool at all. It's a better question, one precise enough that a single measurement can answer what an entire expedition couldn't.